Welcome back to PV Online, and today we're going to do a couple sample problems on calculating acceleration using Newton's second law. All right, the first thing that you need to do whenever you're solving these problems is going to be draw a force diagram. So we have a rightward force of 300 newtons, 2 newtons, is applied to a 28.6 kilogram crate to accelerate it across the floor. All right, so what we have here is we have our horizontal surface and we have a crate. Now, if you want, you can just use a dot to represent the object. But we've got this rightward force, so we have our applied force. So we have this force right here of 302 newtons. And it says it's applied to a 28.6 kilogram crate. So the crate has weight. That's going to be mg. And it's sitting on a surface, so there's going to be a normal. And it says a frictional force. Now, friction is going to oppose motion, so friction acts to the left, and that frictional force has a value of 102 newtons. And the question is, find the acceleration of the crate. So I've done my force diagram. This is where you have to pay close attention to what's happening in both the horizontal and the vertical direction. Now, you need to know from past experience that this crate is going to accelerate either to the left or right. This thing's not flying off into the air, and so that indicates right off the bat that these two are going to be equal and opposite, that the normal is simply going to equal mg, the weight of the crate. Where we start to accelerate is in the horizontal direction. Since the applied force is larger than the frictional force, we know that the acceleration is going to be to the right. Now I put this arrow here and not on my force diagram because it's not a force. So start with the Newton's second law that the sum of the forces equals ma, and a good habit to get into is just always make the larger force the positive one. So my applied force is 302 newtons minus the frictional force, because the frictional force is going to oppose that, equals the mass. In this case, the mass was 28.6 kilograms times the acceleration. So my net force is going to be 200 newtons by subtracting the two horizontal forces. And so when you divide 200 by 28.6, that gives me an acceleration of 6.99, and the unit for acceleration is meters per second squared. So follow those steps. First, do a force diagram, then make sure you focus on which way it's accelerating, then write down your equation, the sum of the forces, and start solving. All right, let's do a second one. So this time it says we have a tension force that's exerted on an elevator. All right, so we have our elevator. And the first thing that I'm doing is the force diagram, and in this case it's being held up by a cable or rope of something with a tension force of 6,580 newtons. And don't forget, it's going to have a gravitational force acting down, and it says in this case that this elevator is moving down. All right, so if I were to take this 521 times 9.8, that gives me a force of 5,106 newtons. All right, my forces are not balanced. And of the two, the tension force is actually larger than the weight vector, which means that I'm actually accelerating up. Now, how could that be? How could you accelerate up if the elevator's moving down? How could the acceleration go in the opposite direction? And that means that my elevator's slowing down. The acceleration's going in the opposite direction of the motion. So now in this case, again, I always just make the larger force the positive one, and 6,580 is bigger than 5,106. That's my net force. The mass of my elevator was 521. And we solve for acceleration. First by subtracting the 6,580 minus the 5,106, and then we're going to divide that by 521. That means I'm going to have an acceleration of 2.83 meters per second squared, and that would be up. Okay, we've done a couple examples. You should be ready to go. We'll see you next time.